Welcome back, everyone, for another deep dive. This time we're going small,
Small.
like really small,
Yeah.
down to the nano world. I think it's safe to say that a lot of our listeners have sent in research about this new X-ray imaging technique,
Yes.
and we're excited to dive in. It's all about seeing the invisible, the intricate structures
Right.
of materials at, their most fundamental level.
Yeah, exactly. I mean, the ability to really see things at the nanoscale, it's completely revolutionizing material science.
Yeah.
Like finally having the tools to understand the blueprint of a building. You can
Yeah.
see each individual brick and how it contributes to the overall structure.
That's a great analogy. And the technique we're talking about today is XLDOT, or X-ray linear dichroic orientation tomography. That's a mouthful.
It is, yeah, but it's a really powerful technique.
It seems like it's giving scientists a whole new level of insight. Can you tell us a little bit more about what XLDOT overcomes compared to previous imaging techniques?
Yeah, so, before XLDOT, scientists were really limited in their ability to see the 3D arrangement of these really tiny nanoscale structures within materials. Imagine trying to understand a complex machine just by looking at its shadow. You might get some clues, but you're missing the full picture. XLDOT is like turning on the lights and seeing that full picture. It shows us the orientation of individual grains or domains within a material.
So XLDOT uses a special type of X-ray to create a 3D map of a material, like a high-resolution blueprint.
Exactly. And it all starts with the Swiss light source, or SLS, which is this giant particle accelerator
Wow.
that produces incredibly bright and powerful X-rays. These X-rays interact with the nanoscale structures within the material, and then by kind of cleverly manipulating their polarization and rotating the sample,
Okay.
we can create a detailed 3D map of how these structures are actually arranged.
That sounds incredibly complex. Can you give us a specific example of how this technique is being used in the real world?
Absolutely. So one example is in the study of catalysts. Scientists used XLDOT to look at a vanadium pentoxide catalyst. Okay.
Which is a material used in the production of sulfuric acid.
Right. Sulfuric acid is essential for so many things.
Exactly. It's a critical industrial chemical used in everything from fertilizers to batteries. And with XLDOT, they were able to actually see each individual grain of the catalyst, the boundaries between them, and even tiny defects in their structure. These features, even though incredibly small, have a big impact on how efficiently the catalyst actually works.
I'm curious what stands out to you as the most groundbreaking aspect of this ability to see these tiny structures.
I think what's really fascinating is that this level of detail, we're talking about tens of nanometers here, allows us to understand how a material structure dictates its properties.
Oh, wow.
And this opens up a whole new world of possibilities for optimizing materials for specific applications, which could lead to, really incredible advancements across all sorts of fields.
So we're not just seeing things more clearly, but we're unlocking the secrets behind why materials behave the way they do. Exactly. This understanding is what paves the way for things like, designing better catalysts, developing more efficient batteries, and even engineering stronger and lighter building materials.
It seems like we're moving from just observing the nano world to actually being able to influence and manipulate it.
That's a great point. And what's even more remarkable is that XLDOT is a non-destructive technique.
Ooh.
Unlike some other imaging methods, it doesn't damage the material being studied.
So researchers can observe changes in the material structure in real time, like during a chemical reaction or as a battery charges.
Exactly. Imagine the insights we can gain from actually seeing how a material's structure changes under different conditions. It's like having a window into the dynamic processes happening at the nanoscale.
Now, that is truly groundbreaking. We've covered a lot about how XLDOT works and its ability to provide this incredible level of detail. But it sounds like the potential applications extend far beyond just catalysts, right?
You're absolutely right. XLDOT has the potential to revolutionize our understanding of a wide range of materials, from biological tissues to semiconductors and everything in between.
So this isn't just a specialized tool for a niche field. It has the potential to transform entire industries. It seems like this deep dive is just getting started. There's so much more to explore. And we're back, still diving deep into the incredible world of XLDOT. Before we took a break, we were talking about all the potential applications of this technology, and it really seems like XLDOT could be a game changer in so many different fields.
Yeah, it really is a game changer. And one of the things that I think is most exciting is its ability to reveal not just the physical structure of a material, but also, how its internal components are oriented, like their magnetic moments.
That's interesting. Can you maybe explain a little bit more about magnetic moments and why it's important to understand their orientation?
Sure. So You can kind of think of magnetic moments like tiny little compass needles within each atom or molecule. And they can point in different directions, and the way these magnetic moments arrange themselves determines the overall magnetic behavior of the material.
So even if individual magnetic moments are pointing in different directions, a material can still exhibit magnetic properties as a whole.
Exactly. So for example, think about antiferromagnetic materials. Their magnetic moments align in alternating directions, so they kind of cancel each other out at a larger scale.
Oh, interesting.
So they don't really appear magnetic from the outside, but at the nanoscale, there's this kind of hidden magnetic order.
It's like a secret code hidden within the material. So how does XLDOT help us decipher this code?
Well, XLDOT lets us see this hidden magnetic world by actually showing us how those tiny compass needles are arranged within a material.
Wow.
And this is really crucial for developing new technologies, especially in fields like, data storage and processing.
Right.
I mean, imagine being able to control the orientation of these magnetic moments, flipping them back and forth to store and retrieve information. That's the basis for so many modern electronic devices.
So by understanding these magnetic properties at the nanoscale, we could create even faster and more efficient electronics.
Exactly. And that's where XLDOT's ability to see the 3D orientation of these magnetic moments is so important. It allows us to study and manipulate magnetic materials in ways that just weren't possible before.
This deep dive really showcases how progress in one area of science can have a ripple effect across tons of different fields.
Yeah.
Before we go too far, I'd love to hear a little more about the team behind this technology.
Yeah, so XLDOT is actually the result of a collaboration between scientists from the Paul Scherrer Institute, PSI, ETH Zurich,
Wow.
the University of Oxford, and the Max Planck Institute for Chemical Physics of Solids.
It's amazing how such a diverse group of experts came together to create this. I'm curious, what do they see as the future of XLDOT?
Well, the team believes that XLDOT has the potential to become a widely used technique at synchrotrons around the world. And that would enable researchers, across various disciplines to really delve deeper into the nano world.
That's exciting. Imagine all the new discoveries and innovations that could come from this. What were some of the key factors that made this collaboration so successful?
Well, the success of XLDOT wasn't just about the technology, It was also about the dedication and expertise of the scientists involved.
Of course.
Particularly their long-term commitment to developing these very advanced techniques with coherent X-rays at PSI.
Okay.
This actually led to an unprecedented level of control and instrument stability at the CSS-XS beamline, which was essential for making these incredibly delicate measurements.
So it was a combination of really brilliant minds, state-of-the-art facilities, and years of research that led to this breakthrough.
Exactly. And it highlights the importance of investing in fundamental research and fostering these collaborative environments where scientists from different backgrounds can come together, to tackle these complex challenges.
It's truly inspiring to see what can be achieved when you get these brilliant minds together with a shared goal. This deep dive has taken us on quite the journey into the nano world, and I'm excited to hear more about the specific applications of XLDOT in various fields. But before we jump into those details, let's take a moment to kind of recap what we've learned so far.
We're back for the final part of our deep dive, all about the nano world with XLDOT. It's been fascinating to learn about this imaging technique and all the new things it's making possible in material science.
It really is groundbreaking. And, as we've been talking about, its potential applications are vast. It spans numerous fields.
Exactly. Earlier, we talked about how XLDOT could completely change things like catalyst design, battery development, and even making stronger building materials.
Yeah, and those are just a few examples. XLDOT can provide this 3D map of a material structure, at the nanoscale, which opens up so many possibilities for innovation. It's like having this brand new, powerful lens to look at the building blocks of our world. Makes you wonder what other breakthroughs are possible with this level of insight.
The possibilities are really amazing. I mean, imagine being able to study the structure of biological tissues in way more detail than ever before, which could lead to all sorts of advancements in medicine and healthcare.
Or maybe we could even figure out the secrets behind these complex things in nature, That could lead to new discoveries in fields like energy and environmental science.
Exactly. XLDOT can reveal the hidden order within materials at the nanoscale, which could completely change how we understand the world around us.
So as we wrap up this deep dive, what's the one thing you want our listeners to remember about XLDOT?
Well, I think XLDOT is more than just, a fancy imaging tool. It's like a window into the nano world, and it gives us this incredible view into how materials are structured and how they behave. And this knowledge can really drive innovation across a ton of fields, leading to a future where we can actually design and create materials with properties and capabilities beyond what we can even imagine right now.
It's been really inspiring exploring the potential of XLDOT, and I have a feeling that this is just the start of its impact on scientific discovery.
I totally agree. The future of XLDOT is bright, and I'm really excited to see what amazing discoveries are ahead as researchers continue to explore the nano world.
It's been great having you, and thanks for joining us on this deep dive. We hope you all found it as interesting as we did. And to our listeners, keep exploring the wonders of science. We'll see you next time.